Hello. Today we'll talk about dictionaries. Today we'll talk about dictionaries, which is yet another data structure. It's a data structure. And as we know, a data structure is a collection. It's a collection of items, right? It's a way of it's a way of organizing items, okay? But under a common variable name, so that they are easy to access. Common variable name. Now, dictionaries are actually very similar to lists. Okay, so I would assume that you have gone through at least the first two lecture videos on lists. If you haven't, I would rather you go back and learn about lists before we come to dictionaries. Okay? So, what is a dictionary? A dictionary is a collection of items, just like a list, as I mentioned before. But unlike a list, the items in a dictionary can be uniquely identified using a key. Okay, this part is important. Okay, this is how it differs from a list. The items in a dictionary can be uniquely identified using a key and not necessarily an integer value like you do in a list, right? So let's say you have a list of numbers or a list of student grades or something, right? So let's say you have this list called grades, and you have uh, let's say you have, I don't know, 8 grades. Okay, you have 8 grades, A plus, A, B, again B maybe, right? A, C, B plus, and A. Why not? Okay. Now, as you know, in lists, each of these elements would be uniquely identified by their index positions, right? So the indexes or indices of these elements are 0, 1, 2, 3, 4, 5, 6, 7, right? So each of these individual grades, right, is like an individual variable, right? So it's like this would be grades 0, right? And this would be grades 4, right? And the way we access each of these variables is by using the square bracket notation, right? The bracket notation, like this, right? Now, another way rather of interpreting this is that each grade is uniquely identified by their indices, right? So the indices are, these are like unique identifiers, right? They are unique identifiers, right? So these numbers 0 through 7 are the unique identifiers of each of these individual elements, right? Now, in a dictionary, these elements can be uniquely identified by not necessarily integer values. Okay, they can be integers. Okay? The integers can be in sequence, but you can also use different types of keys. Okay? You can also use string keys, for example, or the integer keys that you use might be out of sequence, right? So maybe it may be, you know, it may be something like completely out of sequence, such as maybe 7, 5, 2, 0, 1. It doesn't have to be all, like it doesn't have to be consecutive numbers as well. So it can be 100, right? 1,000, right? 999, and so on and so forth. Okay. Finally, they can also be of any type, right? So they can be strings, integers, floats, etc. as well. Okay. Now, each key in a dictionary is associated or mapped to an item. Okay. So in this case, 7 is mapped to A1, right? 5 is mapped to A, and so on and so forth. Just like you'd have in a list in which the index is mapped to the key, but here, I'm sorry, index is mapped to a value, but in case of lists, the key is mapped to a value. Okay, that's the difference. Uh, Now, the keys of a dictionary must be unique within the dictionary. Okay? This means that in a dictionary family, for example, you cannot have two keys named father. Okay, so again, it's very similar to lists. Okay? It's very similar to lists in a list you would have unique keys, right? You have unique indices rather. So this would be 0, 1, 2, 3, 4, 5, 6, 7. They are unique. Just like that, in a dictionary, the keys must be unique. The keys of a dictionary must be unique. Okay, they can be out of order, as I said. They can be out of order. They can be of any type. Okay, they do not have to be of type integer, right? They can be strings and floats as well. And the values of dictionary can be of any type as well. And by the way, this is the same for lists. Okay, this is the same for lists. Um, in Python, right? You can have a list which has multiple types of data. So you can technically have a list, uh, call it A. That's the name of a list. Okay, the list can have an integer. It can have a string, right? It can have a floating point number, right? It can have a boolean variable, right, in the same list. Okay, so you can have this in a list as well. So this is the same for lists. But in dictionary, it makes more sense. It is more natural. Okay, and I'll probably explain what it means, or you'll understand what it means later on in this lecture. But the values in a dictionary can be of any type, and they're often of different types. Okay, in list, it probably doesn't make much sense to do that, but in case of dictionaries, it does. Okay, so that's how a dictionary is similar and different to lists, right? So how does a dictionary look like? Okay, um, so what I'll do is I'll create a dictionary. The name of the dictionary would be family. Okay, and the corresponding keys would be written above each element. So the dictionary looks like this. The name of the dictionary is family, right? And it looks quite similar to a list. Okay, and in this case, the family, let's say the family has 4 members. Okay, family has 4 members. um, and what we will do is we will write the names of the members of the family. Okay, so let's say the names are John, uh, Maria, okay, George, and Helen. Okay, and the keys would be father, mother, son, and daughter. Okay, so these are the keys. Okay, these are all strings, by the way. Okay, and so are the values. The values are all strings as well. Okay, so this is how a list would look like. Okay, the list contains 4 elements. So the size of the list is 4. Size equals 4. uh, the these are the keys which sort of act like indices. Okay, so if you were to declare family as a list as opposed to a dictionary, how would you do it? You would say, it's the same thing, right? It'd say John, Maria, George, John, Maria, George, and Helen. But instead of these keys, what you do, you'd have indices, right? So this would be index 0, this would be index 0, index 1, this would be index 2, and index 3. And the way you'd access these elements is, let's say you want to access John, you'd say family 0, right? That's how you access the first element. And then you'd say family 1 to access the second element, and so on and so forth, right? So a list is positional, or a key is a positional argument. Okay, but in case of dictionaries, there are no positional arguments, so there are no indexes, right? uh, so in case of lists, you have these positional arguments, also known as indexes. But in case of a dictionary, you don't have such uh, positional arguments. Okay, so there's nothing that defines a position per se. Okay, there's no position. You as a user will not know how these are stored. You will not know where is John with respect to Maria, right, or relative to George. Okay, so there is no order. This is not 0, 1, 2, and 3. Okay, but instead they have keys. But it probably makes sense to sort of write them like we did lists, okay? But just keep this in mind that they're not adjacent, okay? They are not adjacent to each other, or I'll say may not be adjacent. It may be even, right? So it may not be these elements may not be adjacent to each other, okay? Now, how would you define a dictionary? Okay. Uh, so the way to define a dictionary, if the keys and values are known beforehand, is like this. Okay. So you state the name of the dictionary and then equal to, right? And then within a pair of curly braces, uh, you you add the key value pairs separated by commas. Okay. And each of these are called, I'll call them key value pairs. Key value pairs, okay? Because it's a pair of key and a value separated by this colon right here, okay? So the example here creates a dictionary of student information, okay? The dictionary is called student, okay? So if I had to draw it, it would be something like this. So the dictionary is called a student. That's the name of the dictionary, right? As you can see, it has 4 items, right? So it will have 4 items, okay? It'll have 4 items. The items would be an, right? And again, remember, this is not positional, so it can be an here, right? And then 8 here, and then Smith here, okay? Smith here, and then second here. So there's no sort of a positional argument, okay? So it might as well be this, okay? So there is no order. So it's not like, Anne is the 0th element and Smith is the first and 8 is the second, right? And so on and so forth. There's no such order, okay? No such order. Just remember this. This is extremely important, okay? But anyways, so you have this, right? You have the dictionary containing 4 items, and each of the elements will have keys associated with them, right? So the key for Anne is first underscore name, and it's a string as well, right? Key for Smith is last underscore name, and that's again a string, right? The key for 8 is age, and the key for class, a second is class, right? That's how we define a student information with the key value pairs, okay? So you'll have the key, that's your key, right? uh, these are your keys, and each key would be followed by a colon, right? And then followed by the values, right? So the values and Smith, 8 and second, okay? There is another way of creating a dictionary, and this way can be used when the elements of the dictionary are not known beforehand, okay? And the way to do it is, we create an empty dictionary, okay, using this syntax right here. The name of the dictionary equals and then a pair of empty curly braces, right? Empty braces. And once we have done that, we can keep adding elements using this syntax. So the name of the dictionary followed by the key in square brackets equal to value. This is the assignment. Assignment of a value to a key, okay? If the key exists, right, its value would be changed. If the key does not exist, it would be added, okay? So just if you remember that we did something very similar to in lists, right? So if you had to create a list in which you did not know the number of items beforehand, right? Or you knew the number of items, but you did not know the what the items exactly were. What you do is you'd say list name equals none times, let's say 4. Okay, and then you would say list name 0 equals something, and then list name 1 equals something, right? 2 equals something. Okay, but there is a small difference. Okay, in this case the list size was fixed. Okay, so you had already defined what the size of the list would be, or how many elements the list will have. Okay, but in this case the dictionary is completely empty. Okay, the dictionary is completely empty. So a proper equivalence would be how you'd create a list when even the number of elements is unknown. Okay, so and the way you do it is you'd say list name list underscore list name equals an empty list, right? And then you would say list name dot append. You use this function, right? Dot append, and then you append whatever you want to add to the list, right? So this is more equivalent in terms of equivalence. This uh, method of inserting elements into a list would be more similar to this method, but instead of the dot append as we do in lists, in case of dictionaries you can use the square bracket notation like you do in lists. Okay, so in this example right here, you start with an empty dictionary. Okay, so initially the dictionary student is empty. Now the next statement says first name equals and remember this is the key, right? This is the key and this is the value, right? This is the key and this is the value. So after you insert the first element, the list looks like this. Okay, so initially it was empty, now it looks like this. It has an element, an. Okay, and the key for an is, you know what, let's do this. So it has an element an, right? Or rather it has a key first name, it has a key first name, first underscore name, and the key has a value of an. Okay, so the list contains uh, a single element. So the next time you add this one, the next key, okay, the last name equals Smith, it adds another element. Okay, so it adds another element where the last name is the key and Smith is the value. Okay, so you keep executing these statements and it keeps adding that key to the list. Okay, so the next time it would add another key. The key is called an age, right? And the value of that key or map to that key would be 8. Finally, it would add another key called class, which will have a value second. Okay, so by the time you're done executing all 4 statements, your list would look like this. Okay, your list would look like it will have uh, 4 elements. Okay, it will have 4 elements. The elements would be Anne, right? Smith, okay, 8 and second, right? And the keys would be first name, okay, last name, okay, age, and class. And again, remember that there is a possibility that these won't be adjacent. Okay, there is no guarantee, so to say, that Anne would be beside Smith. Okay, there is no concept of position. Okay, so you can't think of these as being, together. Okay, so the only way to access these individual elements is by using the keys. Okay, using the keys. So there is no other way you can access these, or you can know for sure what element resides where. Okay, so how do we get a value from a dictionary? uh, as you might have noticed or sort of guessed by now that the way we access an element from a dictionary is very similar to that of a list, which is to say that we use the bracket notation, but instead of indices, we use the keys. Okay, so here is an example of how to access a value. Okay, so we have this list of Olympians, right? Sorry, a dictionary of Olympians, in which we have the key is the name of the Olympian, right? And the value is the function, right? So Zeus is the king of gods, and Hera is the goddess of marriage and whatnot, right? So how it looks like is like so. So you have a list of keys. You have three keys, right? You have three keys: Zeus, Hera, and Ares. And each of the key has an associated value with it, right? So the value associated with Zeus is king of gods, right? King of gods, right? The value associated with Hera is goddess of marriage. Ares is god of war, so on and so forth. Okay. So the way you access a value is by using the square bracket. So if you want to access uh, if you want to access uh, god of war, right, you would use Olympians, that's the name of the dictionary, the square bracket, and the key. Okay, so if you were to write a list instead, right, if you were to store these values in a list, how would you do that? You would say Olympians equals uh, equals king of gods, right? Let's say king of gods as the first element, and then you would say goddess of marriage, that's the second element, and then you'd say god of war, god of war, that's your third element, right? So in this case, the if you were to write a list, the list would have size 3, which is to say it would have 3 elements, right? And the index of these elements would be index equals 0, index equals 1, and index equals 2. Okay, so if you were to access god of war, right, if you had to access this god of war, you would have to say Olympians, you would have to say Olympians and the square bracket 2, right, which is the second element right here. Okay, now the problem is you would have to know where this exists, right? So you would have to know the position where this is stored. But in case of a dictionary, you don't need to know the position, right? What you need to is you only need to know the key. Okay, and the key is sort of associated with the value. Okay, so if this were a list, how would you define this? I'm sorry, if this were a dictionary, how would you define this? So this would be exactly the same, except the indices would be replaced by keys. So the keys are Zeus, Hera, and Ares, right? So next, in case of a dictionary, if you want to access the god of war, instead of 2, instead of 2, you would say Ares, right? You would say Ares, right? That's how you access the, I won't say third because there's no position in a dictionary, okay? But that's how you access the specific value in a dictionary, okay? By the way, it's important to notice that only keys can be used to access an element, okay? Which means an element cannot be used to access a key. So you cannot say like Olympians Ares would return the god of war, but Olympians god of war would not return Ares. Okay, so it's if you were to map, right, the arrow would be just from key to value and not the other way around. Okay, it's a one directional mapping. It's a one directional mapping. Okay, so given a key, you would be able to access the value. So that's information only flows in one direction. Okay, but it's not the other way around. So given a value, you would not be able to find the key. Okay. Now, what if we try to access a non-existing key in a dictionary? Okay, so we try to access a key that does not exist. So in this example, we define a dictionary called family. That's the name of the dictionary, family. And it has, as you can see, it has three key value pairs, right? Father, that's the key, John is the value, mother, next key, Maria is the value, and son is another key, and George is the value, right? So if you were to draw this, it would be family, that's the name of the list, right? The list contains three items, okay? So the list contains three items, uh, okay? The items are John, right? Maria and George, okay? And the keys are father, mother, and son, okay? In the next statement right here, we try to access the value corresponding to the key daughter, okay? Now, what's the problem here? The problem is that there is no key called daughter. It does not exist, right? There is nothing called daughter. It does not exist. This does not exist, right? Which means Python will throw an error, okay? The statement, okay, will throw an error, okay? This is again very similar to lists. So imagine for a second that instead of a dictionary, your family were a list, okay, and the indices were 0, 1, and 2, right? Now if you want to access the element at position 3, it will throw you an error, right? So if you were to say print family 3, this will throw an error because there is the list size is 4, right? I'm sorry, the size of the list is 3. So there is no element at index 3, okay, which is essentially the fourth element. The fourth element does not exist because the size is 3. Similarly, in case of dictionaries, right? If a key does not exist, you cannot access it, okay? If a key does not exist, you cannot access it. However, note that when we talked about creating dictionaries, right? We started with an empty dictionary, right? We started with an empty dictionary, and then we sort of accessed a key that did not exist, right? Because the dictionary is empty, so therefore by definition this key would not exist. This key would not exist. But that is okay because this is assignment, okay? This is assignment. So when you are assigning values to keys, the key may not exist, okay? So during assignment, it's not necessary for the key to exist, but when you're accessing it, right, in this case it's access, so this is access, right, whereas this was assignment, right? So in case of assignment, the key may not exist, it's not necessary for a key to exist, but in case of access, sorry, the key must exist, otherwise Python will throw an error, okay? So how would you change the value in a dictionary? Okay, so how would you alter the value in a dictionary? To alter the value of an existing dictionary element, you need to use the appropriate key and assign a new value to the element, okay? So in this example, we have a dictionary containing just two elements, okay? The elements are these two key value pairs, okay? The key is Indian, the value is Navajo, right? And the key is African, and the value is Zulu. So these are keys and these are values, right? So if you were to draw this, it would be, that's the name of a list, right? And the list contains two elements, right? List contains two elements. The first element is Navajo, and the second one is Zulu, right? And the keys are Indian, and African. Okay. Now, if you want to change one of these elements, let's say Navajo or Zulu, all you do is, let's say you want to change the Navajo, right? You want to change the Navajo to Apache. What you do is you just say dynasties, and then within square brackets you say Indian. That's the key. That's the key. Equals the new value. That's your value, right? So what will happen is, if you do this, this Navajo will be changed. The Navajo will be changed, and it will become Apache. Okay, so that's how you change or modify an existing element. Okay, uh, just to be clear, okay, just to make sure that we're on the same page, if this key does not exist, what do you think will happen? What do you think will happen if the key Indian does not exist? Right? Let's say instead of Indian, we use something else. Okay, what will happen then? The answer is, if the key does not exist and we tried to write the statement, it will add another slot with that specified key, right? Let's say whatever the new key is. I'll just say new key, okay? I'll just say new key and then add the new value. Okay, so if the key exists, it will change the associated value. If the key does not exist, it will add the new key and the new value. Okay, because remember, this is how we have been adding elements to our dictionary, right? When we talked about adding elements to a dictionary, that's what we did, right? We started with an empty list, right? And then we said student, the name of the dictionary, the key equals value, right? And that's exactly what we do here, right? We state the name of the dictionary, and the key, that the value, right? So that's what we have been doing here as well. Okay, but in this case, every key was unique, right? So the list kept on expanding. Okay, at the execution of the first statement, the list size was 1. Then you added the second key, the list size was 2. You added the third one, it became 3, so on and so forth, right? Every time you add a unique key, the list size grows. Okay, I'm sorry, the dictionary size grows. I'm sorry. So every time a new a new key is added, the new is important. Okay, the dictionary grows. Okay, but remember, you can only when I say added, what I meant is new key is assigned a value, assigned a value. The dictionary grows, which means it includes the key in the dictionary. Okay, it does not throw an error. Okay, uh, so that's what we are doing here. Okay, so in order to change the value of an element, all we do is we just use the square bracket notation, right? The name of the list, right? The name of the dictionary, the square bracket, and within the square bracket we specify what the key is, and we say equal to, that's the assignment, and this is the value. Okay, and that's how we change the values of a dictionary. By the way, there is no way for you to change the keys of a dictionary. It does not make sense. Okay, so if you compare dictionary with lists, right, you would not be able to change the index, right? Index of an element, right? It doesn't make any sense. Similarly, you would not be able to delete, or I'm sorry, you would not be able to change the key of a value. Okay, you can add a key, right? You can remove a key. Okay, and removing the key would also remove the value. Okay, remove key automatically implies remove the value as well. Remove value. Okay, so it's not like you remove the key but the value is still there. Okay, so you cannot change keys. You can add keys, you can add key value pairs, you can remove key value pairs, but you cannot change the key for a value. Okay, the only way to do it would be to add a new key value pair with the new key. Okay, so how would you iterate through all the elements in a dictionary? Okay, the general form to do that is this. We say for every key in the dictionary, and remember this in is the membership operator, right? Remember this from lists. This is the membership operator. Okay, so we say for every key in the dictionary, process the value. This means value, right? So if you have a dictionary, let's call it D, right? Dictionary D equals it is a key value pair, right? So let's say it has 4 elements. Let's say it's the elements are A, B, C, and D, and the keys are 100, 200, I don't know, 400, and 800. Okay, just random keys and values. Okay, so what would D100 give you? D100 will actually give you the value A, right? That's what will give you, right? So this would be replaced by the value at that specified key. So here what happens is we say for every key in the dictionary, process, okay, process, that's something that we'll define later on, the value, the corresponding value. This is the value corresponding to key, value associated with key. Okay, and here process is any Python statement or a block of statements that processes the element of the dictionary at that iteration. Okay, so here's the example. The following Python program displays the letters A, B, C, D and their corresponding Morse code. So in this example, the process is just displaying print. That's the process. Okay, this is equivalent to this, the process. Okay, so here's how we do it. We define a dictionary called Morse code, which contains forgive me for the space, there's no space here. Okay, so it contains the keys A, B, C, and D. Okay, so the dictionary looks like this. Okay, it's called Morse code, Morse underscore code. It right now it has 4 elements, right? It has 4 elements. The values are these. Okay, so dot slash, okay, and then this one, I'm sorry, dot dash, and dash, dot dot dot, and this one, right? Dash dot dash dot, and this one. Okay, dash dot dot. These are the 4 values. Okay, these are all strings. These strings have keys, right? What are the keys for these strings? The keys are A, B, C, and D. These are the keys to these 4 values, right? Now what we do is for letter in Morse code, okay, so this would be for every key. Okay, so every key in Morse code, these are the keys. Okay, so for every letter in Morse code, print letter and then the Morse code of that corresponding to that letter. Okay, so this will print A and then a space and then this, right, and then B and then this C, right, and D. Okay, that's what this will print. So for every letter in Morse code, and the letter is the key, so the keys are A, B, C, and D. So for every key, okay, print the key, which is A, and then Morse code of that key. Okay, so which means the value in that dictionary associated with that key, which in this case, the value associated with A is dot dash, right? And the value associated with B is dash dot dot dot, right? So on and so forth. So that's how we access the elements, right? Access all the elements in a dictionary. Now you might have already noticed that in case of list, we could have used something like this, right? You could say for I in range, let's say the length of the list. I'm sorry, length of the list, uh, length of whatever the list is, right? I'll just say list. Then we said list I, let's say we want to print it, right? Let's say we want to print the element in the list. We could say, we just say print list I, right? So we knew that I would range from, if the length of the list, let's say length of the list is 5, we knew that I would range from 0 through 4, right? We knew that. And that is something that we could use in lists. But in case of dictionaries, there is no such integer index, right? This does not exist, doesn't exist, right? The indices does not exist unless you specify your list to be of something like that. Okay, you can actually sorry, you specify your dictionary to be something like that. Okay, so you can have your dictionaries have integer keys as well. If you do that, then you can use a for loop, right? Otherwise you can't. Otherwise you have to use this format right here, which is for every key in the dictionary, process, right? The process can be any function you want. It, in this case, it's print, right? You can also do other stuff with it, right? It can be an expression. Okay, so for every key in dictionary name, process the value, and that's how we access the value in dictionary, right? Value corresponding to a key. Okay, so the approach that we just saw is a read modify approach. Okay, it's a read modify, which means the values of the keys can be modified using this approach. Okay, so here's another example that creates a dictionary. Okay, creates a dictionary and then modifies each of the values. Okay, modifies each of the values. So the dictionary here is the list, the collection of roles and salaries. Okay, and what you want to do is you want to give a $2,000 bonus to each of the employees. Okay, so you have a project manager, that's the key, this is the key, the value corresponding to that is 83,000. Okay, and then you have software architect, and the value corresponding to that is 81,000, and so on and so forth. Okay, so on and so forth. So what you do is, in the next code block, is you say for title in salaries, salaries title plus equals 2000. Okay, which means for every key in this dictionary, where the keys are project manager, software architect, network engineer, sysadmin, software development, right? So for every key in this dictionary, get the value and add $2,000 to the value. Okay, so at the end of this loop right here, when you print all these, when you print the dictionary, each of these values would be increased by 2000. So this would be 85,000, this would be 83,000, this would be 66, 63, right, 72. Okay, each of these values would be increased by 2000. Okay, so when you say salaries title, you have access to the very element, you have actually read modify access to this element. Okay, so this is how we can modify a list, modify a dictionary, I'm sorry. On the other hand, there is another approach in which you cannot modify the elements in a dictionary. Okay, it's just read only approach. So you iterate through the dictionary, but you can only read the elements. Okay, and that approach takes the general form of this. That's the general form. Okay, so here you say for each key comma value, which means for each key value pair, for each key value pair in dictionary name dot items, the dot operator. Okay, this is a predefined function that you can run on dictionaries. Okay, don't worry about the syntax right now or exactly what it does, but it gives you the keys and values for each dictionary, for each elements in the dictionary. Okay, so here you say for each key value in dictionary name dot items, process key and value. Okay, and here process is any Python statement or block of statements that processes an element of the dictionary at each iteration. Okay, so just notice the difference of this form with the previous read modify approach. Okay, in this form, for key value in dictionary name dot items, you process key value, right? Uh, and in the previous form, you say for each key in dictionary, and then you process the value using the square bracket notation. Okay. uh, just just to be clear, just to be on the same page, right, you can also modify the value if you use something like this. If you were to say for each key value in dictionary name dot items process key, and then dictionary name key, then you could change the dictionary name as well. Okay, you could do that, but using the value, using just the value, you cannot, because the value is a temporary variable. Okay. Okay, so if you don't want to use this form, it's completely okay, right? Because the previous form, this form is versatile enough. This form can do everything. Okay, so if you don't want to use the second form, that's completely okay, right? But anyways, so the following Python program displays all elements of the, it's a dictionary, right, at each iteration. So here's the dictionary. So the name of the dictionary is grades, and the elements are John, George, Maria, and Helen, right? These are the keys. These are the keys, right? John, George, Maria, these are the keys. And then B plus, A minus are the values. These are the values. Okay. So here we say for each key value in the dictionary dot items, print, that's our process, print the key received value, right? So this will print John received B plus, George received A plus, Maria received A, Helen received A minus. Okay. So in this case, the grade that we get, right, this is a temporary variable. It does not refer to the actual grade. It is a copy. Okay. In this case, the value is a copy of the dictionary dot key. It's a copy. Okay, so whatever change we make to this value will not actually change the value in the dictionary. Okay, it is just, all the changes would be to this temporary variable, unless you access the element in the dictionary using the format like so, dictionary key, right? Unless you use this format to access a value or to modify a value, the value will not change. Okay, and that's what we do in the previous case, right? We access the value using the square bracket notation. So unless you use the square bracket notation, the actual value in the dictionary will not change. Okay, this is not a square bracket notation, this is a copy. Okay, which is why making changes to this copy will not actually propagate the change to the value in the dictionary. Okay, now in this example, we do the same thing as in the previous example, in that we have a dictionary of personnel and their salaries, right? And let's say we want to add 2000 to each of their salaries. Okay, so here what we do is we create the dictionary like so, like before, and then we run this loop. So we say for title comma salary, which means for every key value pair in the salaries, okay, salary plus equals 2000. Now as you know, this will not change the original values. Okay, so when you print the dictionary after running this piece of code right here, if you print the dictionary, these numbers would be unchanged. They will not change because the salary, right? If you were to say print salary, if you were to say instead of this, if you were to say print salary, it would print 83,000, right? 81,000. And by the way, it may not print in this order. Okay, there is no order, so it may print this one first and then this one and then this one. You don't have any control over that order because they are not positional, right? Just because you defined the key value pairs besides one another doesn't mean they will stay together. Okay, so it might completely change the ordering. So it might say 83,000, then 81,000, right? Then maybe 7,000. I'm sorry, 70,000, and then 64,000. There is no order. You cannot specify an order. Okay, and then 61,000. Okay, keep that in mind. So if you were to print the salary, it would be fine. But if you try and do this salary plus equals 2,000, all it will do is it will change this temporary variable right here. Okay, so that change will not be propagated to the actual dictionary unless you do this. If you do this for title salary in salaries.items, if you do something like this, salaries square bracket title plus equals 2,000, then it's fine. Then it will change it. Then it will change all these. Okay, it will change all these, but you have to use the square bracket notation in order to do this. Okay, the next thing we'll talk about is membership. Okay, and if you have gone through the list videos, you'll know what membership is. Okay, and membership is nothing but checking whether the key, in case of dictionaries, checking whether the key exists in that dictionary or not. Okay, and this is somewhere where dictionaries differ from lists. Okay, in case of lists, right, let's say you have a list of students. Okay, so I'll say list uh, name, that's the list of students. Okay, list name equals, you have a list of size 3. You have a list of size 3. You say the list elements are Charles, Alice, and Bob. These are your list elements. Okay, and the indices or indexes are 0, 1, and 2. Now, in case of lists, if you were to say Alice in list name, okay, if you were to say print right, print Alice in list name, this would print true because Alice is in the list name, right? You could say Bob in list name, it will print true. Okay, but in case of dictionaries, right, this will not print true because in dictionaries you only work on the keys. Okay, so if this were a dictionary, right, this would be, in this case, this is a dictionary with the keys 1, 2, and 3. So these are my keys, right? So 1, 2, and 3. So you could say print 5 in students, and that will say false because the key 5 does not exist in this dictionary. You could say print 1 in students, which will print true because indeed the key 1 exists in the dictionary. But you could say print Alice in students and it will say false because this, even though Alice exists, it exists as a value, and in case of list membership, we only check for keys. Okay, we only check for keys. So that's one of the major differences between a list and a dictionary. Okay. Similarly, for finding minimum and minimum maximum, okay, the min max only works on keys. So this is again similar to the previous slide that we saw. Okay, membership and min max only works on keys, and these are where dictionaries differ from lists. Okay, this is where it's different from a list, right? In case of lists, the min max, right, membership operators, they work on the values and not the indexes, obviously. Okay, but in case of dictionaries, all these will work on the indexes and not the actual values. Okay, for example, when we say print min students, it will output 1 and not Alice. Okay, if this were a list, it would output Alice, but since it's a dictionary, it will only print the minimum of the keys, in which case, in this case, it's 1. Okay. When you say max students, similarly, it will output 3. Okay, because it only cares about the keys and not the values. Okay. So that's how you would find the minimum and the maximum of keys. Okay. Now, how do we, how does it, how do lists differ from dictionaries? Okay. Uh, so as we know that in a list we have a positional index, but in case of dictionaries there's no position, right? There are keys. There are keys in dictionaries, but not indexes, right? So even if you use 0, 1, and 2 as indexes, right? You cannot be sure that Navajo, Cherokee, and Sioux will be together. Okay, so in case of lists, what you do is, if this dynasties were a list, it would look like this, right? It would look like this. It would be the name dynasties, and it would have 3 elements. It would be all very nice. It will have 3 elements. The first one would be Navajo, and remember the first one because the position is first. Okay, the second one would be Cherokee. The third one would be Sioux. Okay, and the indexes would be 0, 1, and 2. This is if it were a list. Okay. Now, although you might think that this is how a dictionary would look like, and certainly might help you, right, to sort of visualize dictionaries in this way, but you cannot be sure that Navajo, Cherokee, and Sioux are like this. Okay, they will not be adjacent to each other. Okay, chances are they would be wide apart. Okay, there might be even gaps in between these as well. Okay, but anyways, uh, so it might not be in this order. Okay, so even if you use indices 0, I'm sorry, keys 0, 1, 0, 1, and 2. Okay, it might happen that your, in case of a dictionary, it might look like this. Okay, it will have 3 values. Okay, the values are not adjacent, which means they might have gaps between them. Okay, and so in case of, like, in terms of RAM, okay, so in a memory, it might have gaps in the RAM between these values, right? And the values may not be in order. So even if it's 0 and 2, okay, it may be something like this. This is maybe Navajo. Uh, this is maybe Navajo. This is Cherokee, and this is, even though the keys are okay. So this would be 0, this would be 1, and this is 2, right? In case of a dictionary. So speaking from a theoretical point of view, okay, there may be gaps in between. There may be gaps in between the elements. Even though the size is 3, there may be gaps. Okay. Also, they might be out of order. They can be unordered. Okay, there is no guarantee that 0, 1, and 2 would be in order. Okay, so when you say for key in dictionary, uh, let's say print key, right? Now there is no guarantee that this will print 0, 1, and 2. Although it might be the case in your Python implementation, or right, in any Python implementation, but you should not rely on this. Okay, you should not rely on this fact. It may as well be 213 or 312. You don't know. Right? You just simply don't know. Okay? It might even change for different runs. Okay, at every different run, you might have a different ordering of these keys. So you should never rely on the ordering of keys in a dictionary. Okay, unless it's specified that maybe, like, it's ascending order or something. Okay, so that's one of the biggest differences between a dictionary and a list. Okay, the second difference is, in this case, right, you can add a value to a non-existing key in a dictionary, right? So in this case, our dictionary is like this. So let me get rid of this list right here. Our dictionary looks like this. Okay, uh, we have 3 elements, right? We have 3 elements. dynasties equals, we have three elements in the dictionary. The keys are 0, 1, and 2. They're not ordered, right? And the values corresponding to these keys are Sioux, or Navajo, Cherokee, and Sioux. Now, when you say dynasties 3 equals Apache, dynasties 3 does not exist. Okay, so what Python will do is it will add a new value with the key 3, and the value would be Apache. Okay, so when you try to access, not access per se, but assign, when you use the assignment, right, and the key does not exist, okay, uh, Python will add that key value pair to the dictionary. Okay, now this is not the same as list. Okay, if dynasties were a list, the last statement would certainly throw an error. Okay, so if dynasties were like this, Navajo, Cherokee, Sioux, which means the indices are 0, 1, and 2. Okay, and which means the size is 3, which means the size is 3, and you try to access the third index, which is essentially the fourth element. So you're trying to access the fourth element in a list of size 3. This will certainly throw an error. Okay, so this is one of the differences between a dictionary and a list. Okay, uh, the other difference is their use cases. Okay, dictionaries are better suited when the data is in a key value format. Okay, and this is a very common format. Okay, think about it. There is a lot of data which are arranged in a key value format, where a key is some sort of unique identifier. The key is a unique identifier. Okay? Identifier, and not just an integer index. Okay, and you might need to query for a key to get its value. Okay? So here's this example. Now the following program searches from a list. Okay, you have list of students. The students have their IDs and their names. Now what we do is we write a program that searches for the student, or rather the student name, whose ID is 371. So how do we do it? Let's try using lists first. Okay, um, we create two lists. The first list is called student IDs. The second list is called student names. The student IDs contain the IDs of the students. So this is the ID of the first student. Okay, this is the ID of the first student, second student, third, fourth, and fifth. This is the name of the first student, second student, third, uh, fourth, and fifth. Okay, so the first student, right, has an ID of 973 and name Sean. The second student, right, whoever it is, I don't know, like I don't know how these students are ordered. Okay, I'm just saying first, second, but essentially it's this guy right here, Ruth or gal, right, has the ID 467 and the name Ruth. Okay, so this is a correspondence. This is the matching, right? So 973, student with ID 973 is called Sean. Student with ID 467 is called Ruth. Student with ID 845 is called Diane. So in this case, these are the unique identifiers, right? Unique IDs, which are not the indexes, right? Because indexes doesn't make sense. So we can have multiple students with index 0, 1, 2, but doesn't necessarily mean that that's how we want to access these students. Okay, maybe the student have different IDs, LSU ID, LSUS IDs, and that's how maybe we want to access them, right? So in such a scenario, if you want to access the student name with ID 371, this is how you do it. Okay, so we'll iterate through every element in the list. We'll iterate through every element in the list of IDs and try to find 371. So we start with this one. Is this 371? No. Is this 371? No. Is this? No. Is this? Yes, it is. This is 371. So for I equals 4, which is the fourth student, is, I know, has the ID 371, right? So student at index 3 has the ID 371. And what is the name of the student at index 3? This is 0, 1, 2, and 3. Student name is Raymond. This is index 3. This is index 3. Okay, so that's how you find the name of the student with ID 371, right? So for I in range length of student IDs, which is 5, right? So for I in range 5, if student ID equals 371, then you print the student name and break, right? Else you continue searching, right? If you find the student with ID this, if you find the student ID 371, print the name corresponding to that ID, right? So this is ID, this is ID 0, 1, 2, 3, 4. This ID 0, 1, 2, 3, 4, right? For every index, check if the ID of that index or ID stored in that index is equal to 371 or not. Okay, and we check each of these, this one, this one, this one, and this one, and then we find that the ID, the student ID at index I equals 3 equals 371, right? So when I is 3, this condition equals true. Okay, so when I equals 3, uh, I equals 3, this condition is satisfied, this condition holds true. So if this condition holds true, we print the student name at that ID. So student names, remember I equals 3, student names 3, which is Raymond. Okay, which is Raymond. So this is what we print, and then we break out. Okay, because we don't, that's okay, because this is unique, right? So once we have found 371, there mustn't be any 371 anywhere else, right? But if we don't find it, if this condition evaluates to false, right, we go back and search for the next I, right? So if this evaluates to false, we go back to the next element and the next element, keep going until this evaluates to true. Okay, so this is how you would search a list of IDs and names, search for a given ID, right, in the list of IDs and names, okay, or search for a given student. However, if you were to use dictionaries in case of lists, it would be like this. It would be, you create the new dictionary, so students equals 973 Sean, right? That's the ID and the name, right? ID, name, and then 467 Ruth, right? 467 Ruth, 845 Diane, 845 Diane, right? So index 012, index 012, right? 371 Raymond, so index 3, ID 371, name Raymond, and 473 Juan, so index 4, ID is 473, index 4, name is Juan, right? So now if you want to find the student name with ID 371, all you do is you do this, print students and then 371. 371 is not an index, but it is a key. Okay, so in case of lists, how it's stored is, you have two lists, each of size 5. The first list, both lists are of size 5. Okay, this one contains, this is the student IDs, so this one will contain 973, 467, 845, right, 371, and 473. And then you'll have the list of names, again of size 5, right? And the names would be let's Sean, right, Ruth, Diane, Raymond, I'll just say Ray, and Juan, right? And the indexes would be 0, right? This is 0, this is 1, 2, 3, and 4, right? Okay, so if we want to find the name corresponding to 371, we have to first go through each of these elements in the list, list of student IDs, find the location of 371, and then use that location to return this name corresponding to that location, right? Whereas in case of dictionaries, what happens is there is no separate separate list for storing the IDs. Instead, the IDs themselves act as keys, right? So it's much easier, it's much easier to find stuff. So instead of 0, 1, 2, 3, 4, you use the actual IDs as the keys. So finding the student ID with 371 is easy. You just use the square bracket notation like so, right? Just use the square bracket notation, and then the list, the key of that student that you want to find. Okay, the key may be student ID, right? Now the student ID may also be a string. So for in this example, the student IDs are numbers, but you can also have strings, right? Let's say the student ID has like dashes and stuff. So you have, let's say, 8 9 8 9, and then 1 2 3, and then 4 5 6 7. If it has dashes, right, you can also use strings instead, right? So because dictionary keys can be any numbers or text or floating points, right, anything, you can actually use these strings as keys, and it would be you finding the name of the student with a given student ID would be very similar. So instead of 371, you would say students, and then within square brackets 8 9 1 2 3 4 5 6 7, right? The exact same thing. So this is in terms of application, okay, this is how a list would differ from a dictionary. So the use case of a dictionary is when you have sort of a key value format, right? Now if the keys were 0 1 2 3 4 5 6 7 8 9 in a sequential order, you would use lists, okay? But if the keys are not 0 1 2 3, right, then it's better to use a dictionary because it's easier to search. It's more efficient as well, as you learn later on in CSC 345, I think, data structures. You'll see that dictionaries are much more efficient when searching, okay, a lot more efficient. So that's the difference between lists and dictionaries, and that concludes this lecture. Okay? See you in the next one. Bye.